In calculus, a commonly used technique is the quotient rule. The quotient rule is used to find the derivative of a rational expression or function. The derivative gives us the slope of the tangent, which is the instantaneous rate of change at a given instant. In general terms, the quotient rule states that the derivative of a function divided by another function is equal to the derivative of the numerator multiplied by the denominator, subtract the numerator multiplied by the derivative of the denominator, all divided by the denominator squared. Here are some examples. Find the instantaneous rate of change of the function h of x equals x plus 1 divided by x minus 3 at x equals 1. The first step is to find the derivative of the function h of x, so let f of x represent the numerator of h of x, which is x plus 1, and let g of x represent the denominator of h of x, which is x minus 3. Now we're stating the derivative of the function h of x, so the first term is the derivative of the numerator, which is x plus 1, multiplied by the denominator, which is x minus 3. The second term is subtracted from the first, and it is the numerator now left alone, multiplied by the derivative of the denominator, which was previously left alone in the first term. And that is all divided by the denominator squared, so x minus 3 squared. Just as a note, those ticks on the x plus 1 and the x minus 3 are signs to show derivative, and I didn't mean for them to look like exponent 1s. I know that the derivative of x plus 1 is just going to be 1 because it's linear, and the derivative of a linear expression is just the slope, so in this case it's 1. And that goes for the derivative of x minus 3 as well, so I'm left with 1 times x minus 3, subtract x plus 1 times 1, all divided by x minus 3 squared. Now I have to distribute the negative onto the x and the plus 1 in the second term, so I'm left with x minus 3 minus x minus 1 all over x minus 3 squared. The x's will sum out, and I'll be left with my fully simplified derivative of negative 4 over x minus 3 squared. Now all I have to do is sub in x equals 1 into the derivative function of h of x. So h primed of 1 equals negative 4 over 1 minus 3 squared, which equals negative 4 over negative 2 squared, which equals negative 4 over 4, which finally equals negative 1. Therefore, the instantaneous rate of change of the function h of x equals x plus 1 divided by x minus 3 at x equals 1 is negative 1. Find the derivative of the function y equals 4x squared plus 25 all divided by x. The first term of the derivative is the derivative of the numerator, which is 4x squared plus 25, multiplied by the denominator, which is x. The second term is subtracted from the first term and is the numerator multiplied by the derivative of the denominator, and that is all divided by the denominator squared, so x squared. To do the derivative of 4x squared plus 25, we break it up into its terms and use the power rule in each term. So that will be 8x for the 4x squared term, and the plus 25 term will be 0. So it's just 8x, and that is multiplied by x. The derivative of x is 1 because it's linear and the slope of y equals x is just 1. So I'm left with 8x times x minus 4x squared plus 25 multiplied by 1, all divided by x squared. So 8x times x is 8x squared, and I distribute the negative across the 4x squared and 25, so I'm left with 8x squared minus 4x squared minus 25 all over x squared. That then equals just 4x squared minus 25 all over x squared, which I notice to be a difference of perfect squares in the numerator, so the square root of 4x squared is 2x and the square root of 25 is 5, so I'm left with just 2x plus 5 times 2x minus 5 all over x squared as my final derivative of the function y equals 4x squared plus 25 all over x.